So we just talked about some concurrency operators. Now we're going to talk about a scheduler operator that can be used in conjunction with the concurrency operators. And we're going to focus initially on scheduler's newParallel, which is going to create a new scheduler which will support a parallel thread pool, which could have just one thread in it, so could be a very lobotomized thread pool, but we'll talk about how to use this operator. So the newParallel operator, which is a factory method on the scheduler's utility class, will create a fixed size pool of single-threaded executor service-based workers. It's a very strange phrasing, but that's what they say in the documentation. So it basically means there's a fixed size pool of these things. The first parameter gives the name to the scheduler, like publisher or subscriber or whatever you want to call it. And the second parameter indicates the number of threads to be part of that pool of threads, pool of worker threads. And it returns a scheduler that's suitable for parallel compute-bound operations. Those are operations that don't block. And in fact, if you try to block, then Project Reactor should complain and throw an exception and do things that will not let it continue. So you can see all the different factory methods here in the scheduler's utility class. There's a bunch of them. I don't even think newParallel is listed on this one, but it's probably a little further down. You can use this to create a custom parallel scheduler. So here's a simple example where we're going to use subscribe on to take a publisher, which is a scheduler, which is a newParallel scheduler, with the name publisher, but a pool size of 1. So it's a very small pool. It's like a baby pool. And we have this publisher. We are going to arrange to run all these operators in that context. So it's going to generate integers from 1 to S max iterations. We're going to ignore the integers and instead, we're going to take each integer. We're going to convert them into unsigned longs. We're then going to generate random big ints from all of this. We're going to get rid of anything that is an even number, because we're going to be doing some prime number checking, so we only want to have odd numbers. Even numbers couldn't possibly be prime, so why bother? And then we're going to subscribe something that's going to omit all the values until we're done. And when everything is finished, we're going to have a finally operator, which will close down the publisher before exiting this stream. Important to remember that the scheduler returned by newParallel is not implemented as a so-called daemon thread. Daemon threads are these special kind of threads that run in the background, and the semantics of daemon threads are that they, by themselves, will not cause a Java process to hang if only daemon threads are left. So in other words, the way to think about this is if you don't dispose of this publisher, like I'm showing here, the app process will not exit, which will cause consternation and chaos and insanity. You'll be like, why isn't my program ever terminating? And the reason is because you have to explicitly dispose of a scheduler created by newParallel. And that's because it's not a daemon, it's user threads. I'm not entirely sure why they did it this way. Once again, it's one of other life's great mysteries, and it's confusing, but just be aware that you have to clean these things up yourself. RxJava does not have an equivalent method like this. There's other things similar to it, but they don't have one exactly like this. So if you use Project Reactor to do something and then you want to port your code to RxJava, you have to think about a different way to do it. RxJava does have a from method on its schedulers class that you could use in conjunction with Java's executor framework in order to get more or less the same effect if you wanted to. And so you could basically create a cached thread pool, a fixed size thread pool, a work stealing pool, and connect that in, adapt it in to work with RxJava. But just be aware that you don't have something quite the same as newParallel out of the box. Now, this is something that's very important to understand. In fact, it'll most likely be on the quiz, so remember to keep this in mind. Project Reactor has this concept of a scheduler. And so the schedulers are separate from other Project Reactor reactive types, like fluxes, like parallel fluxes, like monos. And the subscribe on and or publish on operators in flux, parallel flux, and mono are all parameterized by scheduler objects. And the reason for doing that, the reason for not having those capabilities baked into the flux or the parallel flux or the mono is to enhance reuse, because that way we can have a scheduler's factory method that creates scheduler instances, and that is independent of whether something is a flux or a mono or a parallel flux and so on. So you can kind of think of the schedulers being, like this little thing in the middle, and then they can be used to parameterize all the other different kinds of reactive types that require concurrent scheduling capability. So it's worth kind of thinking about that and wondering why it was done that way. That's the reason why it was done that way. All right, so that's the first discussion of a scheduler instance and operators on the scheduler's utility class that we're going to talk about. There's a boatload of other ones we will talk about as we need to, as time permits, and as we have to talk about those things.